This naturalrefrigerants.com article is being read by an automated voice. Canadian researchers find more atmospheric TFA in the summer and in urban areas. By Michael Gary. Published September 18, 2025. A new study by Canadian researchers have found that the amount of trifluoroacetic acid, TFA, in the atmosphere, formed by the oxidation of HFO 1234YF and other F gases, is greatest in the summer and near urban areas, consistent with the leakage of HFO 1234YF from mobile air conditioners, MAC. The study, Selective Ultratrace Atmospheric Passive Sampling of Gaseous Perfluoroalkyl Carboxylic Acids, was published in the September 1, 2025 issue of Environmental Science, Processes and Impacts by Scientists at York University, and Environment and Climate Change Canada. TFA and many F gases fall under the category of per- and polyfluoroalkyl substances, PFAS, a large number of industrial compounds that have contributed to wide-scale environmental pollution. TFA is part of the subcategory of PFAS called perfluoroalkyl carboxylic acids, PFCAs. The researchers employed nylon-based passive air samplers, PAS, calibrated for the collection of gaseous TFA with the ability to also sample other PFCAs at ultra-trace levels of parts per quadrillion by volume, ppqs. This new PFCA-specific passive air sampling method represents a promising new option for the study of PFCA formation, transport, and fate in the atmosphere, the study said, adding that PFCAs like TFA has been understudied in the atmosphere due to a lack of validated sampling techniques that can be widely deployed. In other studies, TFA has been measured at median levels of 0.76 nanograms per cubic meter in air, 120 nanograms per liter in surface water, 122 micrograms per liter in wine, and 9 micrograms per liter in human blood. TFA has been found toxic in animal studies, and Germany has proposed labeling it in the EU as reproductively toxic to humans. One 2024 study described the proliferation of TFA in the environment, a planetary boundary threat. 3 Canadian sites. Measurements of gaseous PFCAs were performed in 3 areas of Canada: Saturna Island, British Columbia, Toronto, Ontario, 2 locations, and Tadoussac, Quebec, over approximately 1 year. While Toronto is an urban area, Tadoussac is rural and area downwind of urban regions, and Saturna Island is a remote site. The relative mixing ratios percentage of PFCAs generally decreased with increasing carbon chain length, with TFA, the smallest at 2 carbons, substantially higher than other PFCAs. Levels of TFA ranged from 11 to 200 ppqv, while all other PFCAs were between 0.2 and 26.4 ppqv. In Toronto and Tadoussac, the researchers observed seasonal differences with TFA concentrations higher in the summer and lower during the winter. This seasonal trend for gaseous TFA has previously been observed in Toronto and elsewhere, the study said. Seasonal differences for TFA have been attributed to increased photochemical activity in summer, as well as increased emissions of precursors. The study referenced studies linking TFA with the use of HFO 1234YF. No clear seasonal trend was observed for the other PFCAs. Gaseous TFA also followed the trend of being in higher concentrations in urban than in rural and remote locations, with Toronto measurements highest and Saturna Islands lowest. This is generally consistent with the spatial trend predicted by models describing atmospheric formation of TFA from precursors, the study said, referring to a study on the degradation of HFO 1234YF to TFA from use in MAC applications in China, the US, and Europe. The fluorochemical industry points to the UN Environment Program, UNEP, and its 2022 Environmental Effects Assessment Panel, EEAP, report. The report says that TFA is not bioaccumulative, is not expected to pose significant risk to humans or the environment at the present time, and is unlikely to cause adverse effects out to 2100. The report does not comment on the contribution of pesticides and other precursors to TFA since they don't fall under the purview of the Montreal Protocol. The UNEP report noted that deposition of TFA from HFOs and HCFOs will result in greater concentrations near the locations of release. This is unlikely to present a risk to humans or the environment in these locations, but changes in concentration in surface water or soil would respond rapidly to releases, it said. Adding monitoring of the environment for residues of TFA would provide an early warning if trends in concentration indicate rapid increases.